Okay, so now that we've covered the functional groups we're going to cover, mind you, there are more, we just did not cover them all. I want to go into some more complicated compounds, things that aren't just straight chains. There are two parts to this video. First part involves just branching, if all you have is a straight chain with a carbon branch on it, how you name that. The second part of the video is going to be what you do when you have more than one functional group on a chain. So when it comes down to the quiz on this topic, one of these, essentially at the end of the quiz, I'll probably have an even number of questions, like 6 or something, that are related to this video. 3 of them I expect you should be able to get right and will count towards your grade on the quiz. But then if you get all 6 right, meaning that you learned both parts of this video really well, then you'll get some extra credit. Okay? So, when it comes down to branches, not all organic molecules are straight chains. They can get very complicated and have many branches coming off of them. We're going to stick to only branches coming off of the main chain, but when that happens, this is actually something you're kind of familiar with. Whenever we would name a branch off of a nitrogen, we'd call it like the N-methyl, N-ethyl, that sort of thing. The naming is very similar for branches off of the carbon chain. The only difference is that you're going to put a number for the carbon that it comes off of. Okay? The trick with this is because it's carbon chains, is you need to make sure you spot the longest chain before you start naming your branches. Okay? So based on these 2 pictures below, depending on how you name it, you get 2 different names. There's 3-propylheptane or 4-ethyl octane. The rule is, when it comes down to naming branches, is you always find the longest chain possible, and then you name branches off of that. Okay, so the first picture goes with just kind of the visible chain at the top, which counts 1, 2, 3, 4, 5, 6, 7, which is why it's heptane. But if you start from that bottom branch, 1, 2, 3, 4, 5, 6, 7, 8, you actually get a longer chain, which means this is the right way to name it, because essentially you're giving priority to the longest possible connection of carbons in a row. Okay? So, something you'll want to do whenever dealing with these sorts of problems is count off carbons from every direction until you figure out which one is the biggest. Okay? So, some more examples. So we have 3-methylheptane. The numbering on this one, okay, you could have gone from here and gotten 5, okay? Or you can kind of almost see how this is definitely going to be longer. Could have counted that as your main chain. Okay? The one you have to go with is the one that's longer. So that's why this is heptane. And then you can see that on the 3rd carbon and the 5th carbon, there are methyl groups coming off. So it's 3,5-methylheptane. Okay? Next one. A couple of different ways of numbering. We've got 1, 2, 3, 4, 5, 6. Or if I start here, I've got 1, 2, 3, 4, 5, 6. Or just to count one more, this one you find, no matter where you start, you end up with a whole bunch of different ways of doing a 6 chain. Okay? Now, the thing that you want to double check, just to make sure you're not missing something longer, is looking at all of these spots where branches would be coming off and making sure that they're the same. So at my 3s, regardless of the color that if I'm looking at my black 3, I have an ethyl group coming off this way, and an ethyl group coming off this way, and then I have an ethyl up this way and an ethyl down that way, if I'm going based on my black numbering. If So I'm going based on my red numbering. Got ethyl, 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 ethyl. Or if I go based on my blue numbering, got an ethyl group this way, an ethyl group down here, ethyl group up, ethyl group down. So what ends up happening, no matter which way I count, no matter which chain I decide to be as the longest one, at 3 and 4, they have 2 ethyl groups coming off. So honestly, when it comes down to naming this one, it doesn't really matter which one I choose, as long as they all confirm the same structure, 3,4-diethyl-hexane. Okay, so if I had to draw that, I'd draw a 6 chain and then have at 3 and 4 2 ethyl groups coming off. Then I would get the same structure. So last one down here, got 1, 2, 3, 4, 5, 6, 7, 8, 9. Then if I count again, just to make sure, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time I find that I have 2 9 chains. The thing is, with using the blue one, that branch is going to be much more difficult to name, because it's going to be a branch on a branch. So what I'm going to do is I'm going to choose to name from the black 1 through 9, because then each separate piece is its own separate branch, so that's much easier for me to name. So what this will end up being named, when it comes down to naming, especially if you have more than one branching group, priority goes first to number. Okay, and then if you have something, say, on the exact same number, then it will go alphabetical order. But in this case, everything's on different numbers. So I'm going to have the 2-methyl, and then I have a 1, 2, 3 branch coming off at carbon 4. So it's going to be 4-propyl. And then on carbon 7, I have a 2 branch coming off. So that's going to be 7-ethyl nonane. Okay. There is a way to name from this side branch over here, but it gets into things that are more complicated than we've done. So if you run into this situation where you have 2 chains, go with the one that you know how to name. Regardless of how you name it, you would end up drawing the same structure again. So, branching alkanes that have functional groups, again, for the most part, take on the same thing that we did before. You end up doing, 2-methyl or 3-ethyl, whatever the branch is coming off. One thing is that your main branch must include your functional group. Okay? So sometimes, depending on what happens, you might end up having a shorter chain. But another thing with numbering is when you have something that falls at the end, like with this carboxylic acid here, the carboxylic acid, where that falls, that has to be carbon 1. Okay? Regardless of where the branch comes off. The carboxylic acid will always be the first carbon, or with an aldehyde, which always falls on the end of a chain as well, that's always going to be your first carbon, which is why the branch is at 3-methyl. Okay? So, and then when it comes down again to numbering, when you have more than one kind of thing going on, you still want to go with your smallest numbers possible. So this nitrogen falls on the first carbon counting from this direction. Okay? That goes 2, 3, 4, 5, 6, 7, 8. So, and then just to kind of talk about what happens if, let's say this ethyl group wasn't here, it was here. How you would name that would be 3,3 ethyl methyl 1,7 octanamide. Ooh, not mide. Sorry, that should be amine. Octanamine. Okay. Okay, so go ahead and give these a try. See how you do as far as naming goes. And then, so pause the video, try them, and then turn it back on, and I'll show you what I have. Alright, so I have, counting my chains, 1, 2, 3, 4, 5, 6. Or if I count from this end, I've got 1, 2, 3, 4, 5, 6. And if I look at my third carbon, regardless of the blue or the black chain, you have an ethyl and a methyl group coming off. So the name I'd have here would be 3, 3, ethyl, if I could spell, ethyl, methyl, and hexane. Okay. So when it comes down to having a name and then drawing, again I'm going to look at my prefix. That's going to get me going as far as my carbon chain. So I have a pentanone, so that's going to have 1, 2, 3, 4, 5 carbons. Okay, and then I've got, it's 2 pentanones, so that means my double bonded O is going to be at 2. Okay, and then my mistake here should be 4, 4, ethyl, methyl, 2 pentanone. So that means at the fourth carbon, 1, 2, 3, 4, I'm going to have an ethyl group coming off, like so, and a methyl group. Okay, you could draw one of those pieces down too, and that would be fine. So this next one is another one, kind of similar to what I just did, but I've got, if I count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, or if I count the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My blue chain is longer, so that's going to take my ending name, so it's going to be decanone. Okay, and then it's 2 decanone, because that's where the ketone falls. And then based on my numbering, I will have an 8 methyl group. And then one more dash between my word and number. So last one, 3 methyl 2 pentene. So that means I'm going to have a double bond in here, and I need 5 carbons. And the second carbon is going to start my double bond. So I've got 1, 2, double bond. There's my third carbon. 4, 5. Okay, and then my methyl group would come off right there. Alright. So this is the other half of the video. You make the decision as far as which of these methods seems easier for you to do. So let's start talking about what happens if you have more than one functional group on a chain at a time. So these will go back to being straight chains, or frankly for like maybe like a super bonus I might do one where it's got both and a branch. But if there's more than one functional group, there is an order of importance or priority that the functional groups have that determine which functional groups get to take on the end name, and therefore you put their end suffix on, versus becoming just kind of side groups. So carboxylic acids have the highest priority. So if you have a carboxylic acid, your end name will be enoic acid. And then it goes in order from there, from carboxylic acids to aldehydes, to ketones, to alcohols, to amines, to alkanes. Okay? This also means that I'm only going to be giving you these possible functional groups together. So I won't do this with an ester, I won't do this with an amide. Okay? So, the other part to this, when a group doesn't take priority, it's not going to take that ending, but we still need to identify it in some way. So, kind of like how with alkanes you add the YL to the prefix, there's going to be a slightly different way of naming it. So, if you have an aldehyde or a ketone, it's going to be an oxo group. Okay, so you'll put a number wherever it falls, like 2-oxo. Or for a alcohol, it's actually, there's not supposed to be an L on there, it's a hydroxy. It's called a hydroxyl group, but the word you would use is hydroxy. And then the amine will be an amino group. Okay, so let's see how this actually works. So here's some examples for you. The ones at the top, those are what happens when you have a carboxylic acid. Okay, carboxylic acid is always going to take on the end of the name, the one with the main chain length and things like that, because it has first priority. Okay, so a couple examples of hydroxylic acids. If you had alcohols attached to it, right, your butanoic acid comes from the fact that you've got 1, 2, 3, 4 carbons. Okay, and then to indicate where the alcohols go, since there's 2 of them, you say 2,3 dihydroxy. Because you can see they fall on the second and the third carbon. Again, just like with the branching, if you have a carboxylic acid, that carbon automatically becomes carbon number 1. Okay. If you have a carboxylic acid with an aldehyde, like this one, or ketone, again, the main name comes from the carboxylic acid with the enoic ending, so butanoic. But then the aldehyde, or the double bonded O, is an oxo group. Okay, and again, your numbering always starts with the carbon of the carboxylic acid. So it's 1, 2, 3, 4, 4-oxobutanic acid, butanoic. Or if you have a ketone, which is going to fall somewhere in the middle, again, numbering starts from your carboxylic acid. So it's 2-oxobutanoic acid. Right? So an example, when you don't have a carboxylic acid, but say you have the next lowest priority, which would be your aldehyde. Again, the end name, pentanal, comes from your aldehyde, 1, 2, 3, 4, 5. And again, numbering always starts from the carbon of that aldehyde. So we have 1, 2, 3, 4, 5, 4-oxopentanal. Okay. Alright, so here's an example of some things that have lower priorities. We have an alcohol, and we have an amino group attached, and super hard, and also a branch. Okay, so as far as numbering goes here, your alcohol is going to take priority. So it's the lowest number that your alcohol can have. So if we go this way, 1, 2, 3, 4, 5, 6, 7. That gives me a 3 on the alcohol. Going the other way, it goes 1, 2, 3, 4, 5, that's a higher number. So I want to use the red numbering, which is why it's 3-heptanol. And then I add my other functional groups, which is the 1-amino and 1-methyl. Those all happen on... Ooh. Who's catching my mistake? If you notice, based on my numbering, these should both be 2s. So, hopefully my mistakes help you prevent making your own. So, you try with these. I find with these, drawing usually isn't as bad. So to draw this, it's 2-oxo-4-hydroxy propanoic acid. So I'm going to go to that end name first and draw that, and then I will put the other functional groups on. So I need to draw propanoic acid. So propanoic acid, there's going to be 3 carbons. Last carbon has my OH and double bonded O coming off of it. And then numbering wise, hopefully you're catching that there's got to be a mistake in this name. Oops, 2, 3. So my oxo group makes sense being on 2. And then hydroxy is an alcohol, but there is no 4th carbon to put it on. So we're going to say that was supposed to be a 3 and put an OH at the end here. Okay. So next one, here we have a picture. I have an aldehyde group, an amino group, and a hydroxy group. So aldehyde is going to take the preference here, so that means I'm going to start numbering from there. 1, 2, 3, 4, 5. So that means I have pentanol. Alright, I don't need to number where that falls because it always has to fall on the first carbon. And then I'm going to go in order of priority. I have a 2,4-dihydroxy. And I didn't leave myself enough room. A -3-amino pentanol. Okay. So if I write that a little more clearly, it's 2,4-dihydroxy 3-amino pentanol. Alright, so here I have 3-amino, 3-hydroxy, 5-decanone. So I know I'm going to need 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, and I know that on the 5th one, 1, 2, 3, 4, 5, I need to have my ketone. And then on the 3rd one, I'm going to have an OH and an amino. Okay. And then last one, here I have an alkane branch. So that takes least priority out of everything, which means I'm going to name this based on my amino group. Now this is one where I do need to account for branching a little bit. I want to count 1, 2, I could go 3, 4, 5, or I think if I go down I'm going to get a longer chain. 3, 4, 5, 6, 7. So this is 2-heptanamine, and then there's a 2-carbon branch at the 3rd carbon, so 3-ethyl 2-heptanamine. Okay, so I'll have some practice for you guys on Monday, but make sure over the weekend you do get that quiz taken care of.